Okay, so today we're going to be talking about systems of equations. So systems of equations are two or more equations with the same variables. So we're only going to be talking about two equations with the same variables, but it could be more than two. So the solution to a system, graphically, that's what we're going to be talking about today. We're going to be talking about graphically what a solution to a system looks like. So the point where two lines intersect, that's your solution or your answer. So when you graph two lines, where they meet, where they intersect, where they touch, that's your answer graphically. But if you're looking at it algebraically, and this is what we're going to be looking at next time and the time after, there's two different ways we can look at it algebraically. And when you find your point algebraically, it's the point that makes both equations true. But today we're going to be talking about graphically. So next time we're going to look at algebraically. So all you need to know today is wherever the lines intersect, that's your answer for the solution of the system. So let's talk about intersecting lines first. If you have two lines that intersect, for example, this line and this line, they intersect, right? They intersect in the middle right here. This point where they intersect is your answer. So when we graph lines today, we're going to be graphing two lines on the same coordinate plane, and wherever they intersect is your answer. And we're going to write the answer like this. So one solution, you're just going to write x comma y, whatever that point would be. But if you have two parallel lines, first of all, what's the same when you have two parallel lines? The slope, right? So when you have two parallel lines, you have the same slope. So if you see two lines with the same slope and a different y-intercept, you know that it's going to have no solution because they're never going to intersect. They're never going to meet like this line right here. Like these two lines met right here. Parallel lines will never meet, so it's no solution. This is how you write no solution. You write like a 0 with a slash through it. That means no solution in math. If it's the same line, then obviously it's just one line, right? So we can just draw it like that. If you have two equations and it ends up being the same line, for example, y equals 2x plus 1 and y equals 2x plus 1, it's infinite solutions. Remember infinity, how you do it's kind of like a sideways 8? If it's the same line, it means that no matter what point you choose on the line, whether it be this line, this point, this point, this point, this point, all of those points exist on the line, and all of them are going to be the same if you have the same line, right? And a lot of times they'll disguise the same line. Like when you finally solve for y, you're like, oh, that's exactly the same line. Y equals 2x plus 3 and y equals 2x plus 3. But you won't know it until you solve for y. Okay, so those are the three types of solutions. Intersecting lines, it'll have one solution. Parallel lines, which will have no solution because they have the same slope. They never intersect. And then the same line, which will have infinite solutions because it's exactly the same line, right? And we can even draw something that kind of looks like this. So do you see how if you drew a line, it would be on top of it, one line on top of it, which is exactly the same line. So solving systems by graphing, there's three different steps we want to do. So the first step we're going to make sure we complete before we start the other two steps is we have to make sure that we rewrite the equation in slope-intercept form. And remember what slope-intercept form is. It's been a little while. It's y equals mx plus b. I'm just going to say slope-int form. That means slope-intercept form. And this is really important. You know this, y equals mx plus b. Please know that for your final. Slope-intercept form is y equals mx plus b. That's the first step. The second step is to graph the lines. And we're going to be graphing both lines on the same coordinate plane. We're going to see where they intersect, and that's called the solutions. So we're going to identify the solutions. What are our three options for our solutions. These three. It's either going to intersect, the lines are going to be parallel, or it's going to be the same line. It's going to be one of those three. And if it intersects, there's one solution. If they're parallel lines, there's no solution. And if it's the same line, then it's infinite solutions. Okay? All right. So, solve each system of equations by graphing. Step 1. Rewrite the equation in slope-intercept form. Are both of them in y equals mx plus b? Yes. So we can go on to step 2, which is graph the lines. I'm going to draw this first one in red. So the first step, this is really good review for just graphing regular lines. Because the first step here is we have to graph our y-intercept, which is -8. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. I went down because it's a -8. And I'm going to draw that point. Remember when we're graphing y equals mx plus b and we start with b, we start with the y-intercept? We always graph that point first on the y-axis. And then from there, we do our slope. Our slope, remember, is not x. It's the number in front of x, which is a 1. So remember our slope, we write 1 over 1. So we're going to rise 1, run 1, make a point. And then rise 1, run 1, make a point. Okay, rise 1, run 1. Okay, so get the point. And then we're going to graph the next line. So I'm going to graph this one in blue. So our y-intercept is 1. I'm going to graph 1 on our y-axis, and then I'm going to look at our slope. Our slope here, remember we always take the number in front of x and we put it over 1. So -2 over 1. So remember we rise over run. So we're going to rise -2. And we're going to run +1, make a point. Rise -2, run +1. Rise -2. Okay, look, do you see where I just drew that last point? That's going to be our point of intersection. How do I know? Because that's where it hits the red line. So this point is our answer. That's our solution, wherever those two lines intersect. So let's figure out what our solution is. So when we start with y equals mx plus b, we start with the b, which is our y-intercept. So we always start on the y-axis. But when we're finding a point, like this is just a point on the graph, right? This guy right here, the one that's intersected by the red and the blue line. That point, we always start with x first. So we're going to start at 0, 0, and we're going to go over 1, 2, 3, over +3, and down 1, 2, 3, 4, 5. So +3, we always start on the x, and then we're going to go down 5. So it's +3, down 5. That's our solution. Let's try the next one. First step, is it in y equals mx plus b? Yes, both of them are. Second step, I'm going to graph this one in red. We're going to graph the lines. So the first line, it says it has a y-intercept of 9. So I'm going to go up 9. The positive tells me up 9 on my y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make a point. Then from there, my slope is 1/2. So I'm going to go up 1, rise 1, run 2. Now if I continue to go up, I'm going to go off my graph. So remember, we can go rise 1, run 2, or rise -1, run -2. So rise -1, run -2. Because -1 over -2 is still positive. It's still a positive 1/2. Okay. I'm going to draw that line. I drew so many because I don't have a ruler, and I need to make sure it's straight, because at least as straight as possible, because this time we're not just graphing one line, we're graphing two, and we're trying to figure out where they intersect. So it's really important to draw your lines straight. Okay, so 6. I'm going to start with this 6 first. This is my y-intercept. So I'm going to go up 6 on the y line, which is right here. And then from there, I'm going to graph my slope. So remember, my slope is that. Slope which is negative 1 over 1. You always make it a fraction if it's not a fraction already. So we're going to go rise negative 1, run positive 1. I can also go, remember I can also say rise positive 1, run negative 1. And my goal here always is to figure out where they intersect. So do you see how I keep going until I find the place where the point of intersection? So now I know that this is my point of intersection and that's my solution. So I'm going to start at 0, 0, and I'm going to go over negative 2 on the x, negative 2, up 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 8. That is my answer. All right. Let's look at these. Now the first step, remember, get it in y equals mx plus b, slope intercept. This one is not in slope intercept, so I'm going to do that first. All I have to do is get y alone. Kind of nice to do something like this after break since we've done all of this stuff. We're just kind of putting all this together and finding solutions of equations, right? Because we've graphed lines, we've gotten y by itself. We're used to getting it in slope-intercept form, so it's just kind of tying everything together. So that's all we do, y equals 3x plus 8. Now we know our y-intercept. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, make a point. And then this tells me my slope is 3. So my slope is 3 over 1. And remember, okay, if we go up 3 over 1, we're going to go off the graph, right? So instead, I can go down 3. Remember, you can go down 3 to the left 1. Make a point. Down 3 to the left 1. Down 3 to the left 1. Okay. Because that's the same thing. Down 3 looks like this. To the left 1 looks like that, right? Negative 3 over negative 1. This is a positive 3. This is a positive 3. So both of those equal positive 3. That's why we can do it like that. We're not changing anything. Okay, now the next one we have to get the y alone. So how do I get the y alone here? Well, I just have to add x to both sides, right? Now don't forget, we can't do negative 2 plus x. X is a separate term. Y equals mx, remember that x term comes first, and then that minus 2 is afterwards. But we can't say negative 2 plus x is not negative 1x, okay? Because this, unless this negative 2 had an x here, we cannot combine those. So that's our equation, and now we're going to graph that. So negative 2 is our y-intercept, and then we're going to go up 1 over 1. Up 1 over 1. Now, look, do you see how it's going to be intersecting down here? So I'm going to keep going, and I'm going to draw this line. And then I'm going to go back to my red line, because you see how I'm not sure. I want to keep going so I know for sure, unless you had a ruler. I don't have a ruler, so I'm going to continue this slope. I'm going to continue this slope. So I'm going to go down 3 over 1. Okay, make a point there. And then I'm going to go down 1, 2, 3 over 1. Do you see how this is where they intersect? So I need to actually extend that red line. And this is where they intersect. Okay, so what is that point of intersection? Well, whatever it is, that's our solution. So let's find out what the x is first. The x point is negative 1, 2, 3, 4, 5. Right? Yeah, negative 5. And then negative 1, 2, 3, 4, 5, 6, 7. So negative 5, negative 7. And that's your answer. Okay, number 4, and then I'll let you guys try the rest. So number 4 says, okay, so the first step, again, get y alone. In the second equation, y is alone. Great. So we only have to worry about the first equation. So let me rewrite it up here. X plus 2y equals 4, and we want to get the y alone. So the first step is always get rid of the x from both sides. X minus x is 0, that cancels out. We have 2y equals. Now always put your x term first, so negative x plus 4. To get y alone, my last step is divide by 2 to each piece. Remember doing it to each piece? The reason for that is because now we have y equals negative x over 2 plus, what's 4 divided by 2? 2, so plus 2. Now, look here. What number's in front of this x? Not a negative, it's just a negative 1, right? So if I'm going to rewrite this to make it look a little better. So instead of writing negative x over 2, write negative 1/2 x. And then just carry that plus 2 down. Because now I easily see my slope is negative 1/2. Here, especially before we drew that negative 1, it's harder to see that your slope is negative 1/2. That's important when we graph, right? We need to know our y-intercept and our slope. So we start with our y-intercept. Our y-intercept is 2. So let's graph 2 on the y-axis, which is right there. And then we're going to find our slope. We're going to do our slope from the y-intercept. So our slope is negative 1 over 2. So we're going to go from this point, we're going to go down 1, rise negative 1, over positive 2, make a point. Down 1, positive 2. Down 1, positive 2, make a point. Okay. Again, try to make this as straight as possible since we're trying to see where those two lines intersect. Now, let's graph this next line. I'm going to draw it in blue. So my y-intercept is 2, and my slope is negative 1/2. So down 1 over positive 2. You can also go up 1 over negative 2. And look, it's going to be the same line, isn't it? And look at our two equations. Do you see how just from looking here, you cannot tell that these are the same line. But you see how we got y alone? And when we got y alone, look at these two lines. Y equals negative 1/2 x plus 2. Y equals negative 1/2 x plus 2. But you can't tell right away. Do you see how they try to hide that in a different form? So now look, remember when it said we had the same line? This is an example of having the same line. They're exactly the same line. So our solution is infinite solution. So we draw that infinity sign for our solution. Now, what does that even mean? It means that any point that we choose, like let's say we chose this point, that black dot. Do you see how it's on both lines? It doesn't matter which point we choose on this line. It could even be like in the middle somewhere. It doesn't matter. It could even keep going. Anywhere on that line, whatever point we choose for the blue line, for example, is going to be on the red line as well because it's the same line. So that's what it means by infinite solutions. It means any point you pick on either line is going to be the same for the other line. So it's infinite solutions, infinite answers. It doesn't matter what you pick for one line, it's going to be the same answer for the next. Okay, really quick for number 5, I want you guys to do 5 through 8. You have to finish these before you get your homework, okay? But I'm just going to get y alone. I'm going to actually do number 5, but you just have to graph it. So this will be our last one because I want to show you again how to do y equals 7, how to graph that. But I will do this for you as well. So x plus 3y equals negative 15. Remember, our goal here is to get y alone. We always get rid of the x first. Subtract x to both sides. We have 3y equals. Always put the x first, negative x minus 15, because it needs to be an mx plus b. And then we're going to divide each piece by 3. So it's y equals. Remember, there's a 1 in front of this. So this is a fraction. It's negative 1/3 x. And then this piece is minus 5. Great, we got it in y equals mx plus b. Let's graph negative 5. We're going to graph negative 5 on the y-axis first. And then we're going to do rise over run. So I'm going to go down 1 over positive 3, make a point. You can also go up 1 over negative 3 and make a point. that's not negative 3. This is negative 3. Okay, so, and then down 1, okay. Again, I don't have a ruler. So I'm trying to make this as straight as possible. Okay, I just said I wasn't going to graph it, huh? Okay, that's fine. I'll do this one with you and then you do the next 3. Okay, so y equals negative 7. How do I graph that piece? Well, I know my y is negative 7. So where does y equal negative 7? Well, y equals negative 7 somewhere on this y line, doesn't it? On the y-axis. So where does y equal negative 7? It equals negative 7 down here. 1, 2, 3, 4, 5, 6, 7. Right here. That's where it equals negative 7. Now, we always draw our line perpendicular to the axis we're drawing it on. So here, this is y is negative 7. We don't draw it like this. Do not do that. This is how you draw this line. You draw it, it's a horizontal line. Y equals negative 7 is horizontal. X equals negative 7 would look like this. It would be vertical. Okay, so y equals is always horizontal. Because at each of these points, y is negative 7. Do you see how y is negative 7 at all of these points? That's why. You draw it horizontally. Okay, so where does it intersect? It intersects right here. So that's your answer. That's your solution. So we're going to start at 0, 0, and we're going to go over 1, 2, 3, 4, 5, 6. So positive 6, negative 1, 2, 3, 4, 5, 6, 7. So positive 6, negative 7, that's your answer. So try 6 through 8, and then show me when you're finished.